Okay, guys, so yesterday we learned about what rational expressions look like. Remember, it's a fraction that has a polynomial in the numerator and the denominator, and we learned how to simplify them. Today we're going to look at how we can multiply them and also divide them. Okay, so it's actually not much different than what we did yesterday, so that's good news. Just a reminder that you can find this packet on Google Classroom. If you could print it out, that would be amazing. But everything else is there, the notes, all that good stuff. And you might just have to take notes in a notebook or anything like that if you do not have the ability to print. Sorry about that. I wish I could get packets to you. Right, so let's jump into this. We're first going to multiply rational expressions, and we have two options. If we just have monomials, which remember that's just single terms with no addition or subtraction, separate anything, we can multiply everything together first and then simplify. If we have any binomials or trinomials, then we're going to factor everything first before we simplify. So first off, let's take a look at number 9 here. And these guys are all monomials. So I'm going to multiply my numerator and multiply my denominator. So my new numerator is going to look something like this. 6 times 10 is 60. X squared and x cubed is x to the 5th. Y cubed and y to the 4th is y to the 7th. My denominator is going to be 2 times 18 is 36. X squared, and that's the only x I have down there, and then y squared times y squared is y to the 4th. Okay, so if I go ahead and I simplify this guy down, okay, I got 60 over 36. That's going to simplify down. I think 6 goes into both them, right? Actually, even bigger than that, 12 goes into both them. So 12 is going to simplify down to 5. 36 divided by 12 is going to be 3. Right? And then I have x to the 5th over x squared. I subtract those exponents to get x to the 3rd. And then I got y to the 7th over y to the 4th. That's just going to be y to the 3rd. So it looks like my answer would be 5x cubed y cubed over 3. Okay, so number 10 is pretty similar, all monomials. So pause and then give it a try. And unpause when you're done, and I'll run through this guy. So I'm going to multiply my numerators and get something like that for my numerator. And then I got 15 times 12 is 180. A times a to the 4th is a to the 5th. And b to the 3rd times b to the 7th is b to the 10th. And then what I'm able to do is simplify this guy's down. 20 actually goes into 180. So 20 over 180 is the same thing as 1 over 9. And then a to the 5th over a to the 5th, those guys are just going to cancel. We're not going to have any a's left, right? And b to the 8th over b to the 10th, when I subtract them, I get b to the negative 2nd. But remember, with a negative exponent, you got to just cross the line and change the sign. So that's actually going to become a b squared in our denominator, and we're all good. Okay, so on the other hand, if we don't have monomials like we had in numbers 9 and 10, and instead we have binomials and trinomials, we're going to factor everything. Okay, so we got to go ahead and factor every single part, every numerator, every denominator. So check it out. First I'm going to do this guy, 4x squared minus 4x. My GCF is 4x, and I'm left with x minus 1. And then I'm going to go ahead and work on the denominator here. Okay, I'm going to do some side work just to keep everything somewhat pretty. So I'm going to pull a 2 out first, right? 2 goes into everything. And that leaves me with x squared plus 2x minus 3. And then I'm going to be able to factor that guy down into x. It's going to be x plus 3 times x minus 1. Right? I just decided what two numbers multiply to negative 3 and combine to positive 2. And then on the right-hand side, x squared plus x minus 6. I can factor that guy. It's a trinomial. And I'm going to do x, I think it's x plus 3 and x minus 2. And down below, I can pull out a 4x. And I'm left with x plus 2. Okay, so we have a lot that we can cancel here. It looks like x minus 1 is on top and bottom. X plus 3 is on top and bottom. You'll notice that I can still cancel because there's multiplication involved here. I can cancel even from one fraction to the other as long as it's in the numerator and denominator. And then you'll notice I have 4x and 4x. Right? But then after that, I'm all good. So it looks like up top, x minus 2 is all I have left. On bottom, 2 times x plus 2. Right? And then let's check out number 12 real quick. Right, so this guy, I'm going to factor everything because you'll notice I have some binomials and trinomials. I'm going to pull a 5v out of this first expression and be left with 2 minus v. Down below, I'm going to factor this trinomial into something like v minus 9 times v minus 2. Up top, I got v minus 9 times v plus 1. And then 15v I can't really do anything about. So it looks like v minus 9 cancels, right? And then you'll notice I have 5v and 15v. So they're gonna cancel, except this is gonna be a 1 and this is gonna be a 3, because 5 over 15 is 1 over 3 and the v's will cancel. And then 2 minus v over v minus 2. If you look back to our other page, we have to remember that a minus b over b minus a is equal to -1. That's one of those scenarios there. So these guys will simplify down, but we're going to actually have to throw a negative out in front. So we're going to do negative v plus 1 over 3. I'm going to run that negative through those guys and get negative v minus 1 over 3. Okay. So when it comes to division, it's actually really similar to multiplication. We have to use a little trick. Okay? To divide rational expressions, all we have to do is multiply by the reciprocal. Some of you guys might remember a little trick that you've done back in the day when you're dividing fractions called keep, change, flip, where you keep the first expression, you change the division to multiplication, and you flip the second expression. And that's essentially all we're doing. So for example, this guy, I'd start off by just rewriting as 5pq over 16p cubed times 8q to the 5th over 35p squared q squared. And then I'm going to just go ahead and multiply these guys out. So that's 40p q to the 6 over 16 times 35 gives me 560. And I'm going to have p to the 5th and q squared. And then I simplify it down. 40 actually goes into 560. 40 and 560, that's 1 over 14. Okay? So I got 1 over 14. P over p to the 5th, it's going to be p to the -4th. And q to the 6th over q squared, it's going to be q to the 4th. That negative exponent I got to get rid of. So the q to the 4th stays up there, but that p to the 4th goes in my denominator because it had a negative exponent. And I'm just going to show you one more. All right? So let's go ahead and check out number 15. So the first thing I would do is I would rewrite this guy using my keep, change, flip trick, right? So, which is where I'm going to change it to multiplication, but then I got to flip this guy. And now, because I'm dealing with binomials and trinomials, I factor everything. So this guy over here, I'm going to do 2a squared as my GCF. I'm going to be left with a minus 6. Down below, that's going to be a minus 6 times a plus 2, I believe. This guy is going to be a minus 5 times a minus 3. And this is going to have 8a squared as our GCF, and it will leave us with 3 minus a. Okay, so we got a lot going on. Let's see what we can cancel. A minus 6, they're gone, right? And then we have 2a squared and 8a squared. The a squared is going to cancel, right? And then 2 over 8 is just 1 over 4, actually. And then finally, the last thing we can do, a minus 3 over 3 minus a. That's that weird scenario that simplifies down, but we have to throw a negative out in front because they were kind of the opposite of each other. So we're going to put a negative out in front, and then I have a minus 5 left over. And on the bottom, I have that 4, and I have the a plus 2. I'm allowed to rearrange that 4 and the a plus 2 because they're just being multiplied. So to finish off, I'm going to distribute that negative to the top, and I got my answer. Okay, so that's multiplying and dividing rational expressions. To practice, I want you doing the odds from 7 to 19 on homework 1. Okay, remember, office hours from 11 to 1 if you need help.